Hello and welcome to the first video for 8.4. We are talking about radicals still, but we're going to look at it in a slightly different way. Okay, so up to this point we've talked all things roots and radicals, something like the square root of 16 is equal to 4. We talked about simplifying the square root of 18, but we've never really talked about any other way we could represent a radical. A radical can also be represented as an exponent. If you remember, the square root of a square, we end up just getting a whole number back, right? So if we had, for example, we'll go, I don't know, over here, the square root of 6, and then we squared that, those two things cancel. We end up getting a whole 6 to the first. Okay. Now this we can also do with just exponents. If I had 6 to some power and I raise that to the second power, then I could force this to equal 6 to the first if I have found out what x was. Okay. Basically, what would x be? If I had something times 2 equals x, so 2x equals 1, and it looks like x would be 1/2. In other words, if I were to plug in 1/2 here, and I times that by 2, I get back to 1. You can almost think of it as like you're dividing the power, which is kind of what, if you think, generally, very loosely about it, because it's not actually division, but if you think about it, that's kind of the division of powers, right? Division of exponents. And so we can represent any radical as a fractional exponent as well. Another example for you here, we have 3 to the 1/2. We see that if we had 2 of those, we end up getting 1 or 3 to the first, right? And so again, we see it canceling back. It works with other powers as well. If I had 8 to the 1/3, that's the same thing as the cubed root of 8, because if I multiplied 8 to the 1/3 and I cubed it, they cancel each other out, just like a cube root and a cube do. They cancel each other out, and I get 8. I can do it with a fourth power. 16 to the 1/4 to the fourth cancels each other out, and I get 16. If I raise this to the fourth power, I get 16. And so if that happens, then those two things are equivalent. You've got 2 to the fourth power. So let's practice rewriting some of these fractional powers into radicals, and then backwards, some radicals into fractional powers. So if I have 64 to the 1/3, well, then what I want is the cubed root of 64 in radical form. So my index is taken from that denominator of the power. And then I can do a quick double check. 64 to the 1/3 cubed would be the opposite. And the cubed root of 64 cubed in both cases, they cancel. I end up getting the 64. And so we can see that the denominator of the fraction is the same thing as having that 3 as the index number. Now, what is the cubed root of 64? The cubed root of 64 is 4, which we know from previous chapters. All right, 100 to the 1/2 power is not 50. Be careful. We are not simplifying by multiplying. It's very important. It's not 50. It is the square root of 100. Okay, now normally we don't write the 2 there. Okay, you don't have to write it here, but I wanted to draw the comparison there that the denominator became the square root. And yes, of course, the answer to that is 10. Now, the next two are very, very similar. It kind of draws on something we have to be very careful about here. When things are in radical form, it's very easy to see whether things are included or not within that radical, right? If I'm looking at, we'll go here, square root of -8, I know that does not exist versus the negative square root of 8. You see how that's very obvious that negative's not included in the second one, but it is included in the first one. Not as obvious when you're dealing with exponents. Okay, when you're dealing with exponents, it's a very subtle game and you have to be very careful. For example, this first one, that 1/4 is not applying to the negative. It's as if we have -1 times this expression over here. Whereas in the second one, we see that that 1/4 is actually applied to the negative. So in the first one here, I'm going to get a -4th root of 256, otherwise known as 16. I'm not quite sure, to be honest with you. Let's see. Fourth root of 256. Nope, it's 4. It's 4. Cool. Whereas in the other one, the fourth root does include the negative 256, and since that's an even power with a negative underneath, this one actually does not exist. So you can take an answer from a, well, I forgot to write for negative, or at least maybe I did, it just got roped into my equation there, or my equal sign there. So the first one, it gave me a nice, beautiful -4, whereas in the second one, I can't even compute it, right? And it's all for a lack of parentheses. So we have to be very careful about all that. Mostly, this conversation comes into play when it's talking about even powers, right? But it does happen with odd powers as well. If I were to change this one to negative fifth root of 32, I would be incorrect because that negative is actually a part of the expression. And so I'd want negative 32 being fifth rooted. The difference between this one and the last one is that that doesn't derail the problem, right? There is a fifth root of negative 32. It's negative 2, as we've seen in previous chapters. Once again, I have it in the parentheses so that negative 8 will become under the radical. The index number would be 3. And that also does have an answer of negative 2. So hopefully you're starting to see how this idea of a rational fraction can create a radical, right? One more illustration for you. 2 to the first, 2 to the second, 2 to the third. We get 2, 4, 8. Now, if we were to go the other way, we were given 8, 4, 2, and we wanted to go down, we wanted to cut things out, then we could rewrite these as fractional exponents. So going this way is up, going that way back down with fractional exponents. Maybe that helped, maybe made it worse. I don't know. So let's work a little bit more with this. As you know, 3 to the 1/3 is the cubed root of 8. I'm sorry, 8 to the 1/3 is the cubed root of 8. But what would 8 to the 2/3 be? How would that work? So if I have something like that, I can split it up using the laws of exponents. There is a law of exponent that says I can multiply two powers together, which means I can also take them apart again. And so if I take them apart, instead of 2 over 3, I have 2/3, 2 1/3. Then I have the cubed root of 8 being squared, and I can deal with the cubed root of 8 parts first. So the cubed root of 8 is 2, and then the 2 squared gives me 4. Let's do another one of those, just kind of ease into it. This one, not so bad. You just get the square root of 36, which we know is 6. Over here, though, I'm going to rewrite this first as a 1/3 being squared, not a 2/3. So instead of a 2/3, I have 2 1/3. And then I can just deal with in the parentheses, change that to a cubed root of 125 being squared. Well, we know the cubed root of 125, it's 5, and 5 squared is 25. So you can see how if you break the pieces apart, it's almost just like a multi-level puzzle. It is since they're both exponents, it is entirely the same thing to say 125 squared to the 1/3, but you have to admit finding the cubed root of 15,625 is a little harder than doing 5 squared. So either way you go, you get the same answer, but you may want to deal with the fractional part first. All right, next up we have another negative versus fraction situation here. This negative is on the outside, and we need to be careful about that. So let's just separate it all together. Very similar to what we're doing with the fraction exponent anyway. Separate out that -1. And then we'll just keep it over here. I'm going to go ahead and separate that fraction now. Instead of 5 halves, I have 5 1/2, which means I have -1 times the square root of 4 to the 5th power. We'll head over here now. -1 times, well, what is the square root of 4? That would be 2 to the 5th power. -32, which is what this simplifies to. Now, you could sit here and try to figure out 4 to the 5 halves power. 4 to the 2.5. 4 to the 2.5 power is also 32. Okay, and then you tack the negative on. But dealing with decimals, especially maybe it's not a whole number, right? You want something that's like, if it becomes a decimal itself, you definitely want to keep it in radical form. All right, let's try this one. This one we have the negative within the parentheses, and so that cube root, I'm sorry, let's back up a second. That third power, that 1/3 power, is applied to both the negative as well. Now we see that the cube root contains the negative. What is the cube root of negative 27? Does that exist? Yes, it does. It is negative 3. And negative 3 squared gets me a positive 9. Cool. All right. If you might be wondering, if I were to choose the squared option first, wouldn't that change my signs? Not quite, because the squared would just be taken care of from the beginning. Negative 27 squared would be the same thing as 27 squared, which is 729 to the 1/3. Or the cubed root of 729, which is also positive 9. So you don't have to worry about negatives coming into play if you were to switch the order as well. All right, this last one, we've got a negative 100 included. So negative 100 to the 1/2, I have 3 of them, which means the square root of negative 100 to the 3rd. And the square root of negative 100 does not exist, and so does not exist to the 3rd still does not exist, and so we get a broken problem. Again, you don't have to worry. If you were to do it the other way and do the cube first, well, whoops, I don't know why I wrote a negative there. Let's try that again. All right, if you were to do the cube first, you'd get negative 10,000. Just double checking that, I'm pretty sure. Nope, just kidding. That's squared. 1, 2, 3, 4, 5, 6. Negative million is what you'd actually end up with. And if you take the square root of that, you still end up with does not exist. So that negative is still there. You don't have to worry about which way you go. Alrighty, let's play around with one more version of this. We're going to look at what happens when you have a negative in there as well. Okay, this is pretty much as crazy as you can go. So you've got 4 to the negative 2. Just a reminder, this is a whole number here. We're not even dealing with a fraction yet, but this is just a reminder. What does it mean to have a negative power? Well, that means 1 over 4 to the positive power. So in other words, 1 over 16. Basically what's happening is you've got 4 to the first is 4, 4 to the second is 16, 4 to the 0 is 1. And if we go backwards, we're following this pattern of dividing by 4. So 4 to the negative first would be 1 divided by 4. 4 to the negative second would be 1 divided by 2 fours. And if we kept going to the negative third, it would be dividing by 3 fours, and so on and so forth. And so we see the negative creates division, whereas the positive, the positive numbers make multiplication. Okay, so we see going both ways. We see it dividing and we see it multiplying. Which means if we tack this on to the negative fractional power, we're going to have to keep that in mind. But again, it just becomes 3 pieces roped into one little part. So I've got a 25 here that is being negated. We'll say negative 1/2 to the 3rd. We can even break it up even more. To the negative first, to the 1/2. Actually, let's put the negative on the outside. Not that it matters. It just might be a little easier to deal with this way. So let's put the 1/2 inside, put the 3, and then the negative 1. So we're separating all 3 aspects of this rational fraction, this fraction exponent. Okay, let's deal with the 1/2 part first. That would make it a square root of 25 to the 3rd to the negative first, which would be 5 to the 3rd to the negative first. 5 to the 3rd is 125 to the negative first. That's 1 over 125. So 3 separate moves because of 3 parts of the exponent. So we have to keep that in mind. When you have a negative in there, there's 3 parts to it. All right, I think we'll tackle this one now with the fraction, and then you can try out D on your own and see how you do. We've got each one of these in this fraction being applied this power. Oh, it's not a 5, Miss K, it's 27. Okay, so now each one of these, we have 8 to the 1/3 to the second to the negative first. Now, if you don't like this splitting idea, you don't have to do it on the paper. You could just do it in your head, but you do have to deal with all 3 parts. And we've got 1/3 2, and negative 1. Okay, I'm going to have to clean this up a little bit. Cubed root of 8 squared to the negative 1 over the cubed root of 27 squared to the negative 1. I'm going to go ahead and kind of bleed into this next problem a bit. Just like section it off a little bit. Okay. What is the cubed root of 8? The cubed root of 8 is 2. And now that's being squared to the negative first. Over what's the cubed root of 27? 3 squared to the negative first. 2 squared is 4. 3 squared is 9. Both of which are now to the negative first. And if they're both to the negative first, this whole fraction is just going to flip upside down. And so we get 9 over 4 as our final answer. Now, it may, in this case, may have been nicer to flip it first. Since you have a negative on the whole fraction, we could have just flipped it from the beginning. You could have squared it from the beginning. You could have taken the roots like we did. And each part is interchangeable. So it is entirely up to you what you think the fastest route is, but you must deal with all three aspects. You can't just keep it as 4/9. You can't just keep it as 2/3. You can't just keep it as 8 over 27. All right, go ahead and try this last one on your own. And I will stop talking for a couple seconds so you can pause the video. All right, hopefully you had a chance to pause the video. 81 to the 1/2 third and then negative 1. The square root of 81 is 9. So we get 9 to the third to the negative first. 9 to the third is 729. To the negative first would be 1 over 729. And again, you could have done the negative first. You could have done the cube first. That's fine. But that is the final answer. The last thing I'll say for this video is be very careful of your negatives. Negatives can be placed in a variety of places when it comes to a exponential expression. Okay, it could be in the fraction as we are dealing with right now, right? In which case you get a fractional answer. It could be on the outside as a coefficient, in which case you get a negative answer. It's actually a whole entire separate one. And you could have both, in which case you get a negative fraction. You could also, it's the same conversation can be said for a whole power versus a fractional exponent, right? So you have a lot of different little pieces with this, which is often what I see people make mistakes on. We're going to go ahead and visit this again in our next video with some rules for simplification of these powers. And I'll see you there.